Hey, this is Math 7, Unit 7, Lesson 3 on non-adjacent angles. And so we're looking at angles today that are not right next to each other. So they are not right next to each other. So for example, if I had something like this, and this, and this, I might be looking at this angle over here and maybe this angle over here because they are something in between. So there's something in the way, so they're not right next to each other. So these are non-adjacent angles. Remember, adjacent means really next to. So that is there. This is going to be not next to. So first of all, in the first activity, it says finding related statements. Given A and B are numbers, and that A plus B equals 180, which statements must also be true? So, we decide what works. So for sure, we know that this is always true, given the statement. So we know this is for sure, A plus B equals 180. So what else could be true if this is true? So for example, is A going to be equal to whatever 180 is minus the value of B? So think of it this way. If I had A plus B equals 180 as being true, if I subtracted B from both sides, I'd end up with the B going away there, and I'd have A equals 180 minus B, which is matching this right here. So this first statement would indeed be a true statement, right? We can show that just with some algebra for how that's going to be true. Over here, if we say A minus 180 equals B, you might think of using algebra again, right? If I use algebra again, it'd be hard to get that setup to be like that. You can't move things around. However, here's the thing. This becomes a not always kind of situation. The reason it's a not always is because we don't know what those numbers are. They could be any set of numbers. It could be 90 plus 90, right? If this was 90 plus 90, then we would say 90 minus 180 doesn't equal 90, so that wouldn't work. But are there numbers where it could work? Think about this. What would happen, for example, if A was actually equal to 180, and you had an 180 minus 180? What would that be equal to? Well, you'd say, well, that'd be equal to 0. Well, you'd be right there. Well, what if I took those same values of A and B and put them up here? What would 180 plus 0 be equal to? It would still be equal to 180. So this true statement would still be true, and it would work for those values there. So while this equation might look like something that wouldn't quite work, it could work if you use a number like 180 and 0. It's a possibility. Let's look at this third one here. We have 360 equals 2A plus 2B. All right, and we're not sure exactly what that means, but we could say, well, I could factor over here a 2 out of this side, and I'd have 2 times A plus B. And over here, I could factor 2 out of that, and I have really 2 times 180. Now, knowing that I factored 2 out of both sides, if I was to divide both sides by 2, that becomes simply 180 equals A plus B, and that certainly matches that equation right there. So this equation would be one that would always be true no matter what. So we have a true, a not always, and a true statement here. How about this one? A equals 90 and B equals 90. Well, does that work? If you plug that into there, is that a true statement? If 90 is A and 90 is B, well, 90 plus 90 sure does equal 180. That's going to be true. But are we for sure knowing, do we for sure know that A and B are 90 each? We don't know that for sure. So we would say not always. And that's because A and B could be any two numbers that add together to make 180. I could have 100 plus 80, and that makes 180. So there are other options that could work there. So this would be a not always kind of statement. Let's move down to the second section. Use any useful tools in the geometry toolkit to identify any pairs of angles in these figures that are complementary or supplementary. Now remember, complementary means that the angle pairs add up to be 90 degrees, and supplementary means the angle pairs add up to be 180 degrees. And so again, you can use any tool you want. If you chose to use, for example, like the protractor here, I could measure an angle like this one right here, and I could say, well, I'm going to go on that line at 0, and I can see that this one right here is going to go, looking at my line here, a little bit below between 60 and 50. And so maybe I would say that on mine, again, yours paper might be a little different because mine's a photocopy. Okay, maybe mine is about 58 degrees. So perhaps I say angle A is 58 degrees. Okay, now let's take a look at what angle B is. Angle B right here, when I look at this one starting at the 0 at this point, okay, I move this over here starting at 0, and I'm going to be opening it up to here. So I'm looking over there. I'm somewhere around here. Looks like I'm at about, oh gosh, I don't know, 120, I don't know, 120 something, 122, let's say 122. All right, now why do I say 122 degrees? Well, if I did 122 plus 58, what does that add up to be? That's going to be 8, that's going to be 180 degrees. Now the reason I'm going to say that's probably going to be the right measurement is because these two angle sums together are going to be supplementary. So we would say that angle DAB and angle, in this case here, ABC are 180 degrees. They are supplementary. All right. Now knowing that this is a parallelogram, I have a side and a side, this side and this side here, then this angle right here would also be 58 degrees, and this one over here would also be 122 degrees. You can check that on your own if you chose to, but then because that's true, we can also say that these two angles are also going to be supplementary, 58 plus 122. So you could also again say that angle ABC and angle BCD add up together to give you 180 degrees as well. So in this parallelogram, I have several sets of supplementary angles. I don't have any complementary. They're not going to add up to be 90. 58 plus 58 doesn't give you 90. Not going to work there. In this next shape here, I notice that I have and there are, by the way, a couple more combinations. I'm just giving you two. I have here a 90-degree angle right there, which tells me that these two angle measurements are going to be a combination of some number that's going to be a complementary angle. But let's use our geometry tool, use our little protractor here to see what we come up with. So I put my my point right there, I get my thing on the line right there, and as I go 0 to there, I notice I'm at about 20 degrees right there. So that's going to be 20 degrees in that space. And then if I do the same tool over here, I'm starting at the 0, and I'm going to go all the way around to there. I measure it around, it looks like I'm ending up right about 70. Again, just kind of approximating 0 up to 70. I know it's a little bit off, but that's okay. My angle measurements may not be precise here. And the reason I'm going to do 70 is why? Because 70 plus 20 are going to be 90 degrees, and that's going to be a complementary angle. So I could say that angle EGF and angle GFE are complementary, and they add up to be 90 degrees. Okay, and again, if you reverse the order, the E and the F here, the E and the G there, that's okay. Remember, the one in the middle is the angle that you're actually looking at. That's the measurement you're looking at there. All right, and that's the idea. On the next activity, it says, this is called vertical angles, and vertical angles is a big part of what today's activity is about. Okay, vertical angles. So we're going to use a straight edge to draw two intersecting lines. And then we're going to use a protractor to measure all four angles whose vertex is located at the intersection. So what does that mean? It means we're going to take our paper like this. We're going to draw a line like this here, using a straight edge there. And I can draw another line like right here. Okay. All right, and line there. So I have two lines here that are intersecting at this point right there. There's my intersection. Okay. Now, I'm going to go ahead and just label some points here just so I know what I'm talking about. I have A. I can put a point here and we'll call that B. Put a point there and call that C. Put a point there, call that D. And we'll label the vertex right here as E. So I'm just labeling points on these two intersecting lines that we've drawn. Now, using these two intersecting lines, I have created four angle measurements. And I'm going to use a protractor to measure those now. Now yours will be different. I'm just, making my own up here, so mine will be different than yours. That's okay. So when I look at the first one, I see that I have an angle starting at 0 right here, and we have our line that goes just past 60, and so we're going about 62 degrees right here. So this angle measurement right here would be 62 degrees. What's interesting here is that if I look at the angle directly across from this one, right across, we call this a vertical angle. And when I see what the angle measurement of that one is, what I'm going to discover is, look at this. We start here, and we're at 0. Oops, bumped my protractor there. Sorry about that. Put it back on the line. And I'm going to start at the 0 spot. And as I go around, where do I end up? 60, 61, 62 degrees. So this angle here is also 62 degrees. So we would mark this by saying that this angle equals this angle, and those are both 62 degrees. We refer to those degree measurements, or these angles, because they're directly across and equal to each other, as vertical angles. All right? Now, I could figure out what the rest is going to be here. I could take a look at this other angle measurement, and we can measure this here, plotting that there at the 0, and then going around, we go to 110 all the way to this point, which is about 118. Again, starting at the outside, because that's where the 0 is for this bottom line here. Okay, my bottom line is here at 0, and so we're going to go all around the exterior there up to 118. So this angle measurement here is 118 degrees, which means this vertical angle across from it is also 118 degrees. So it says, compare your drawing and measurements to people in your group. Make a conjecture, that means what do you think is true, but aren't certain, about the relationships between angle measures at an intersection. Well, what we could say we think is true is that the angles across one another are going to be equal to each other. So if this is 62, then across there is 118. And that's what we find out when we take a look at those there. We could also take a look here, just as an added bonus, and notice that from here to here is a straight line. And so because that's a straight line, I can form a straight angle by adding those two things together. So 118 plus 62 is going to add up to 180 degrees, verifying that I have a straight line and a straight angle right there. And that's part of the idea there. All right, in activity 4, it's the row game with angles, and it says what it wants you to do with a partner here is find the measure of angles in one column, and then with your partner work on the other column, and then check with your partner after you finish each row to see how your answers match. They should be the same. If your answers aren't the same, work to figure out why that is and find the error and correct it. So noticing first of all in this first column, I have, and you can go ahead and do this here with your partners. If you want to press pause, it's fine. But I'm going to go ahead and work with it on it with you. What we have here is we have a straight angle, so we know we have 180 degrees, and it tells me that I have 134 already shown. So to find out what remains, it's 180 degrees minus 134 degrees there will give me A. And so when I borrow there, I end up with 46 degrees being the missing measurement right here. When I look on the right side on column B, I know my answer should be the same. Let's see why that is. Well, in this case, I have a complementary angle, right? This was supplementary, so here I have complementary. And so I'm going to do a 90 degrees, make it complementary, minus the given 44 degrees. And when I do 10 minus 4, I have 6. 8 minus 4 is 4. And so 46 degrees here matches 46 degrees here. In this case, I have a supplementary one. In this case, I have a complementary angle there. We do the same idea for the other ones here. Again, this becomes a complementary angle. So I would do 90 minus 51 in order to come up with a value of 49 degrees for angle A right here. And this, because I have a triangle, these two angles combine to make 90. This one already is a 90, and so the other angle measurement is going to be 90 because the sum of the angles inside of a triangle equals 180. So I'm going to have 90 there. So 90 minus 51, again, would be 49 degrees for this missing measurement right there. Let's take a look at the next side. All right, on this next side here, this is a great one. We have this trapezoid right here, and it says angle C and angle E are supplementary. So this one and this one are supplementary. Supplementary means that they combine to be 180 degrees. So let's take away what we know, the 129, to find out what we don't know. So we subtract and we end up with 51 degrees is the angle measurement right there. On B, this is another great one. I like this one a lot because again we have a supplementary angle and we add all three of those together, right? To go from here all the way around is going to be 180. So let's take a look at what we already have. We have a 95 and 34. Let's add that up real quick. we have 129 from here to here, but I still have to find out what's left. So what's left? Well, I do 180 minus 129, and we are left with 51 degrees for this angle measurement right there. All right, next one, find the value of C. A great question. Again, notice that I have a complementary angle right there, which means that these two angles combine to be 90 degrees. They gave me the 42 already, so what is left is going to be 48 degrees, and that goes right there. Using that information, you could say that you know also what the value of A is. If this is 48, then straight across, or D, sorry, that becomes 48 degrees. And since that's 42, straight across there, that becomes 42 degrees. So you can actually solve for those as well. Over here, it says B is on the line FW. So here's a line, and B is on that line. Find the measurement of angle CBW. So we want to find this space right there. Notice once again that I have a supplementary angle there when I combine all three of those angle measurements together. So let's first of all find the sum of those two, which is 67 and 65, which gives me 132. So that angle measurement there will be what's left, 180 minus 132. We borrow and we end up with 48 degrees is what's left here. So I have 48 degrees and 48 degrees. Again, they should match. And finally, this last one, no picture, it says two angles are complementary. Complementary means what? They add up to be 90. One angle is 37, find the other. Sure. So we know they have to equal 90. So 90 minus 37 is going to tell me what's left. So that's going to be 53 degrees. Here we have two angles are supplementary. That's 180. One of them is 127. What's left? Well, let's find out. 180 minus 127. We borrow here, it's going to be again 53 degrees. Again, your answers should match, and check with your partner. So in summary, in today's lesson here, we're really talking about vertical angles is one major thing, that when two lines cross, they form pairs of vertical angles. Vertical angles are across the intersection point from each other. And that really is one of your big takeaways from today's lesson. All right, so they are across this intersection like this. So you might want to at times use some color markers like this to show that these are going to be the same, right? Those are going to be the same. And this one on the outside here, this larger obtuse one, is going to be the same as this larger obtuse one here. Okay? It's going to be the same there. So vertical angles always have equal measure. Okay, and we can see that because they're always supplementary within the same angle. So they form supplementary angles when you look at what's going on in the straight lines there. And that's the big part, a big takeaway for today's lessons. All right, so work on your homework and then come back and let's take a look at it together. So pause the video, and see you in just a second. All right, number one, it says two lines intersect. Find the value of B and C. Okay, so great question here. Couple ways of doing this, and there's several approaches. You might notice that you have a supplementary angle happening right here in this section. Could be. You might also first notice that you have vertical angles happening here in this section. It doesn't matter what you see first. You can do however you like. I'm going to go ahead and go with the vertical angle first. Why? Because that's pretty easy. If this angle right here is 42, right, in this space, then the vertical angle straight across from it, because they match, is also going to be 42 degrees. So I know that B is equal to 42 degrees. That's pretty straightforward there. Now for the C, I could use this angle or this angle, but either way, I know that I have a straight angle right here that has to add up. I'm going to erase my little curves for now, okay? I know I have a straight angle from here to here that forms a supplementary angle, right? That's supplementary. So 42 and C, like this. 42 plus C is going to be equal to 180 degrees. We know that to be true. So to solve for C, I subtract 42. So we have 10 minus 2 is 8, 7 minus 4 is 3, and don't forget that 1. So C is equal to 138 degrees. So we have an answer for B and an answer for C. Great question. Number 2. In this figure, angles R and S are complementary. Again, what's complementary? They add up to be 90. So what do we know? We know that we have 62. We could write an equation like this. 62 plus angle S, right? Angle S is going to be equal to 90. So when I find out what the angle S is going to be, we subtract 62 from both sides. So S is going to be equal to 90 minus 62 is 28 degrees. And that's what's missing right here, 28 degrees. Number 3. If two angles are both vertical and supplementary, can we determine the angles? So the vertical and supplementary, which means, think about a picture. You have something like this and something like this, okay? Now these two angles here have to be vertical, right? So we're looking at two vertical angles. We can call it A and we can call it B if we wanted to. But those angles are vertical, but to be supplementary, what do they have to add up to be? They have to add up to be 180 degrees. Now for them to be supplementary, we actually could call this A and A because they're going to be exactly the same. So we could really say it's A plus A equals 180, or 2 of the A's equal 180. So what is 1 of the A going to be? Well, divided by 2, A is equal to 90 degrees. So for it to be both vertical and supplementary, the angle would have to be 90 degrees. It is possible to be vertical and supplementary if it's 90 degrees. That's the first part of the question. The second part says, is it possible to be both vertical and complementary? Vertical and complementary. Okay, can you get vertical and complementary? So complementary means what? You're going to have an angle plus the same angle equal to 90 degrees. So 2A is going to be equal to 90. So when you divide by 2, what would that angle measurement need to be? It would have to be 45 degrees. So if we had a straight line like so, okay, let's pretend this is about 90 down the middle there. So 45 would be somewhere about here, right? Again, this is just sketch. I might have a 45 and a 45, and those two 45-degree angles would be vertical, and they would add together to become complementary. So that could work. Yes and yes for both of those. So that's my mathematical way of showing it, and you can write an explanation as well. Number 4, it says match each expression in the first list with the equivalent expression from the second list. Alrighty, so let's see what we have here. First of all, I have this question here, which I can expand this out. I can go 5x, that becomes 5x plus 5 plus 1, or 5 times 1 is 5, minus 2x plus 11. I can combine some like terms, so 3x minus 5x minus 2x equals 3x, and 5 plus 11 is 16. So 3x plus 16, that matches right there. Alright, so number A goes to 4. Got it. Next one, here's a 2x and a 2, so that combines together to make 3x. And I have a 2 and a 5, that combines together to make a 7, so I have a 3x plus 7. Do I see that anywhere else over here? Not right away. Don't see it quite yet. So let's come back to that one. Here we have a negative 3/8 and a positive 5/8. So 5 minus 3 is 2. So I have 2/8x. Negative 9 plus 1 is minus 8. But a 2/8 is really the same as 1/4 x minus 8. So do I have a 1/4 x minus 8? Sure I do, right here at number 1. So C goes there, no problem. So we got A out of the way, we got C out of the way. We have B broken down to that, but we don't have a one that matches quite yet. Here we have a 2.06x, all right, and then I have all of this. Over here I don't have any decimals, but I have a 2.06. Let's see if I can make some sense of this. Here is minus 5.53, and here is adding a negative. That's the same. Here is plus 4.98, that's the same. Here's minus 9.02, and here's adding a negative, that's the same. So this one here is going to match that equation right there. Here I have 99x plus 44. I don't see a match. Let's take a look up here and see what I can do. I can't do anything else with that, really. Actually, I could factor out an 11, because 11 goes into there 9x times, and I could factor out a 4. So that matches right here with some factoring here, which leaves me with this one going there. Why is that? Well, 1/2 times 6x is going to be what? 3x, and 1/2 times 14 is going to be 7. So those are going to match directly across there. Perfect. All right, number 5, factor each expression. 15a, 13a, 15 and 13 have nothing in common, but they both have a. So let's take an a out. And we have a times 15 minus 13. And that's it. Here we have negative 6, negative 18, x and y. Let's take a negative 6 out of the whole thing. So we're left with here just an x, because negative 6 times positive x will be negative 6. And I have a negative 18, so let's make this a positive right there. 6 times what gets you to 18? 6 times 3. And again, negative 6 times positive 3 can give me the negative 18, and we'll keep the y with it. Over here I have 36 and 54, and of those I know that 9 goes into there and 9 goes into there. They both have an a in common, so let's take a 9 and an a out of both terms. 36 divided by 9 is 4, and what do I have left? A b and a c. And over here, 54 divided by 9 is going to be 6. And what do I have left? Just the d. And that's it for that one. Okay, number 6 is another great question here. It says the directors of a dance show expect many students to participate, but don't yet know how many students will come. The directors need 7 students to work on the technical crew. The rest of the students will work on dance routines in groups of 9. For the show to work, they need at least 6 full groups. They need 6 full groups working on dance routines. All right, so we're going to write an equality to represent this situation. Inequality means we're going to be using greater than and less than, right? So, how do we do this here? We know that they're going to have a certain number of students who are going to come. We don't know how many students are going to come. That's our unknown variable right now, is students. So we'll call that S for students. There are going to be students that come. Now, of the students that come, they're going to have to right away take away 7 to work on the technical crew. So I'm going to take away 7 right away. All right? Now, let's say 10 came. If 10 came, we do 10 minus 7, and you're left with 3 people left, right? But I need to, whatever's left, I have to divide that by, I want groups of what? Groups of 9. So my groups of 9. Okay, so my groups of 9. Whatever I have, I'm going to take away 7 of the kids to work the tech crew, and then divide what's left by 9. For the show to work, they need at least, which means I need to this has to be at least, has to be greater than or equal to 6 groups. The only way I can get this to work is I have to have at least that. I know it says least, you want to think going the other way, but I want it to be greater than 6 groups or equal to 6 groups. If I had to be less than, it wouldn't work. So my equation would look something like this. To solve this here, I can rewrite it nicely without my arrows. This is my 6 full groups where I got the information. I have 7 minus s divided by 9 is greater than or equal to 6. To get rid of the 9, I multiply both sides by 9. That goes away. So we have s minus 7 is greater than or equal to 54. I can add 7 to both sides. And so s is going to be greater than or equal to 61. Now as a graph, if I was to graph this out here, here is 0, here is 61. I'm going to do a closed circle because it's greater than or equal to, so it's closed circle, and it's greater than or equal to 61, so I'll draw an arrow looking something like this, like that. And that's the idea for that first part there. Part B says write a sentence to tell the directors about the number of students they need. Okay, so based upon this information, what would you tell the directors? We would say you're going to need at least 61 people in order to get your 6 full groups. You have to have at least 61 people. Now ideally, because you want groups of 9, you probably want to then kind of work up in increments of 61 plus 9 more is going to be 70. You know, if you got 9 more from that, you can get 79. So some good numbers to work with might be 61, 70, 79. If you have other numbers than that, it might not work out too well for your groups. Your groups will be uneven, but it's not ideal. All right, let's look at the last one. It says that a small dog gets fed 3/4 a cup of dog food twice a day. Okay, so that's 3/4 of a cup of food twice a day. So 3/4 plus 3/4 is equal to, we could say it's equal to 6/4. That's the same as 1 and 2/4, and that's the same as 1 1/2, right? Which as a fraction is 1 1/2, as a decimal is 1.5, depending upon what you want to work with. Use D for the number of days and F for the amount of food in cups. and write an equation relating the variables. Sure. So what do we know? We know that the dog gets 1.5 cups of food each day, right? And that's going to be how much food it's going to have. Okay? So the food that he gets each day is 1.5 each day. So this is my day. So if he has one day, think about it this way. If he has one day, how much food will he have? He's going to have 1.5 cups. If it was 2 days, 2 days of food, you'd multiply that out and he would have 3 cups of food. So it'd be 3 cups. Does that make sense? So 1.5 cups of food. That's our equation. So our equation is 1.5D equals F. The question then says, use the equation to say how many days a large bag of dog food will last if it has 210 cups of food in it. So if I have my equation 1.5 days and I know that I'm given 210 cups of food, now I can solve for the days. So I'm going to divide both sides by 1.5, 1.5. So here's 1.5 on the outside, 210 on the inside, right? 210 is on top, just like a wrestling match. He won the prize. He gets to live inside the house. I don't want to mess with the decimal there, so I'm going to move it over one space. But by doing that, I need to move this decimal over one space, put a placeholder there, and immediately put a decimal up top. Call that my satellite dish on top of my house. 15 goes into 2 0 times. 15 goes into 21 1 time. So that's 15. We subtract here. 21 minus 15 is 6. Bring down the 0. 15 goes into 60. We would say 4 times. Okay. That's going to be 60 there and a 0. And bring down a 0. It goes into 0 times. We have 140. So how many days would the food last for? It's going to last for 140 days. That's how long 210 cups of food would last for that dog. That's it for the day. Have a great one, and we'll see you next time.